Hi everyone, welcome to Quadep Econs Academy. Today we're going to derive the product rule of differentiation from the first principle. We urge you to look out for our earlier lesson on the derivation of the power rule. With that lesson, we have shown how we come about with the first principle of differentiation, and that will be useful for those who don't understand the first principle of differentiation. So this is the relation given for the first principle of differentiation. What we're going to do today is to find the derivative of y, which is equal to j of x multiplied by I of x. So y is a product of two functions, and our duty is to find the derivative of y. To be able to apply the first principle, we need to find f of x. And in this case, f of x is j of x, I of x. We also need f of x plus h, and that is j of x plus h, I of x plus h. So we are going to put this into the function and solve for the product rule. Good. After doing the substitution, this is where we are. I need to simplify this fraction, especially the numerator side. The easiest way to do it is to be able to do some factorization. But how it stands now, it will be difficult to do such factorization. So I'm going to work around it. What I will do is that I will pick one of the factors here and one of the factors here and multiply them to get a new term. And the term that I get, I'm going to subtract it from the numerator. When I do that, this is what I have. But you can clearly see that by subtracting this new term, I have changed the original problem. So I need to take it out. And this is how I will do it. To take this new term out so that we return to our original problem, I will just add it. So look at what we are now having. The new term that we subtracted, we have also added it. So technically, the 2 will cancel out and it will be 0. So at the end of the day, I still have my original problem. Because after all, I subtracted a new term and added it, which implies that the new terms that have been added or subtracted altogether become 0. So this new fraction we are having is the same as our original problem. Doing this, however, gives us some ease to work with our problem at hand. What we can see is that we can have common terms. Let's compare the term written in black and the one in red. We see that j of x of h is a common term here. So let's factorize it out. When we factorize it out, this is what we have. That is not the only common factor. When we come to these factors, the term in green and the term in black, we see that we also have a common factor, that is I of x. Let's also factorize that out. So when we factorize that out, we also have this. So at this point, what we have done is that we have factorized out the common terms. Now, let's proceed and distribute h for the two terms. When we do that, we have the first part over h and the second part over h. Let's do some rearrangement. So what we do is that we have taken out j of x plus h to multiply the fraction here. Now, when we do this, something comes to mind. We see that the fraction here is just a derivative. When we cast our minds back to the first principle of differentiation, we see that if we have I of x plus h minus I of x over h as the limit of h approaches 0, then this is the derivative of I with respect to x. So that is what I'm going to do. So instead of the fraction, I now write it as the derivative of I with respect to x. Let's consider this side too. We can bring out I of x. So when we do that, I of x is going to multiply the remaining fraction. But clearly, this is also a derivative. J of x plus h minus j of x over h is the derivative of j with respect to x. So I can also rewrite it as this. Now this is where we are. At this point, let me apply the limit of h approaching 0. That means that where I see h, I will put its value to 0. And when I do that, I'm going to be left with j of x multiplied by the derivative of I with respect to x plus I of x multiplied by the derivative of j with respect to x. So what we have here is the product rule of differentiation. So when you are given y equals j of x I of x, then its derivative can be obtained by applying the product rule, and that can be done by multiplying j of x by the derivative of I with respect to s and adding the product of I of x and the derivative of j with respect to x. So this is the product rule. Now let's try to use this rule to solve for one question. We are given y equals 3x squared multiplying 8x cubed. So y can be considered as having consist of two functions, which are j of x and I of x. So here, our j of x is 3x squared and our I of x is 8x squared. Now, we want to apply the product rule. So, we need to do substitution here. We need the derivative of I with respect to x. So, we need the derivative here. So, from the power rule, what we do is that we multiply 8 by 3 and subtract 1 from the exponent. When we do that, we will have 24x squared, and that is the derivative of I with respect to x. We also need the derivative of j with respect to x, and from the power rule, we are going to multiply 3 by 2 and subtract 1 from the exponent. When we do that, the derivative of j with respect to x will also be 6x. So now we have all the values. This is that, this is that, this is here, and that is here. So let's do substitution. So when we do substitution, we have what is down here. So now our duty is to simplify this. Let's multiply this and that, and also multiply this and that. By doing so, we will get 72 x to the power 4 plus 48 x to the power 4. This times that will give us this, and that times that will also give us that. So x and x here are of the same degree, so we can simplify by adding the coefficients, and by doing that we have 120x to the power 4. So this is the derivative. So what we have seen is that given y equals 3x squared times 8x cubed, we can apply the product rule to arrive at this. Let me also state that you can go straight away to multiply the two terms, and after that you apply the power rule. You get the same derivative as this. But let me say that it's not always easy to multiply the two functions and apply the power rule. And it is in those circumstances that the product rule becomes handy. So that will be the end of today's lesson. I need you to support my channel by subscribing, liking, and sharing. Thank you for watching.